Okay. Oh, we're already on. Well, wonderful. Welcome this morning to the spring session here at on Thursday at DevOps. It's elaborately named Modern Enterprise Java Architectures with Spring Framework 4.1. But it's fundamentally a kind of fresh 2014 perspective onto the Spring component model and a little bit of the Spring configuration model as well. So from my personal perspective, Spring is very much about the design of application components. It's really a kind of tool to assist you in translating your component model arrangements, your component model vision, your application architecture onto a concrete runtime, Java-based runtime setup. Spring is kind of a tool to make that happen for you. And the design perspective is very important in that context in particular. Spring goes a long way and goes many extra miles in fine-tuning its own design and the design that it allows for in your component model to just make things sweet, readable, concise, and just coherent and consistent across the code base. We are also going to talk a little bit about the architectural perspective itself. Spring also being a kind of means to make an architecture happen, an architectural vision that is in your heads, right? An application architecture that you designed, that you came up with, that makes sense in your environment, in your systems, for your business purposes. And Spring allows you to translate that architectural vision into a concrete arrangement. These days, that's a pretty interesting affair. There are many target deployment scenarios. There are many kind of system architectures. This space is really becoming more and more interesting in later years, and these days in particular. Just talk about messaging-oriented architectures, talking about reactive programming, etc., etc. The multitude of data stores that we're integrating with, data grids, so many things playing into this. Modern web architectures, not even to start with, what kind of challenges a modern web architecture is facing with the different clients and the load scenarios that it needs to be able to cope with. All right, so much for a quick introduction, what the motivation behind this particular session is. My personal role is being the Spring Framework lead. So I have been running the Spring Framework project, the open source project, for many years now, basically since its inception. And I keep pushing forward. So the Spring Framework 4.x, the Spring Framework 4.x line is what I'm involved with on an everyday basis. I spend a lot of time designing Spring Framework for 2014, for 2015's environments. There is a 4.2 generation coming up next year as an advanced note, so we are very actively developing this piece of software at the very moment. All right. So just to summarize a few of the kind of target architectures that we're working with, that we are working towards these days. Just in the past year, really, we've been focusing heavily on kind of non-traditional deployment architectures, such as using Spring Boot with an embedded web server, integrating with local relational databases or non-relational databases. We've been strongly focusing on the use of WebSockets. This turns out to be one of the most popular features in the entire Spring Framework 4 generation. A strong focus on messaging, and we'll return to that, of course, in concrete examples in just a bit. Messaging across the portfolio. Messaging with Stomp on WebSockets. Messaging with annotated Jms endpoints. Messaging with AMQP and RabbitMQ. Messaging in Spring integration. A consistent messaging experience across the Spring portfolio. So this has been really an effort beyond Spring Framework itself. Spring Framework 4.0 has just been an opportunity to make all of this happen across other projects, such as Spring Integration 4. We've also taken the opportunity to raise the baseline. So just to make that statement at the very beginning here, Spring Framework 4, including the very recent 4.1.2 released just a few days ago, is based on Java 6+. It's still Servlet 2.5 compatible. It's also as an important minimum, it requires JPA 2.0 now. We did raise the baseline, right? No Java 5 anymore, no JPA 1.0 anymore. However, this still goes back quite a bit. In concrete terms, Spring Framework 4.1.2, released just a couple of days ago, is still compatible with WebSphere 7 as long as you installed IBM's JPA 2.0 feature pack. That's a 2014, late 2014 version of the framework, working on a 2008 generation application server with the most modern features that you could expect. Of course, we are running into limitations of what we can do there, but as much as we can do, we are doing on Java 6 and WebSphere 7, for example. At the very same time, there's a strong focus on Java 8. Spring Framework 4 has often been associated with Java 8 even. Spring Framework 4 is built with Java 8. It got released 3 months ahead of Java 8's GA with full Java 8 development support. It's very much right after Java 8 general availability. We came up with production support from our side, so we are really tracking Java 8 very closely. There's a consistent Java 8 story across the framework. At the very same time, it's Java 6 compatible, works great on Java 7 obviously, but if you're running on Java 8, Spring Framework 4 is going to, and 4.1 in particular, is going to feel like a Java 8-based framework to you. You won't really notice, unless, I mean, there are of course spots where you can, if you're really diving deeper, but from a general application development experience perspective, you won't notice that it's not Java 8-based, right? It really feels like a Java 8-based framework to you. All right. To wrap up this introduction and go right into code samples, at the very same time last year, we also took the opportunity to support a selection of the latest EE7 level specifications. Quite a few of them are of significant relevance to a Spring Framework arrangement. The obvious ones are Servlet 3.1, which we of course caught up with. Tomcat 8 got released recently, where we've been giving a lot of feedback to. JSR 356 WebSocket ties nicely into our WebSocket strategy, although Spring's WebSocket strategy is not actually JSR 356 only, but it's JSR 356 compatible if you have it in your runtime environment. It's at least based on it, can be based on it if you have it in your runtime environment. JSR 236 managed concurrency. A great spec, came way too late in EE, very important to modern day Spring architectures. If you want to do any asynchronous processing driven and initiated by Spring, by your components running in a Spring environment, then we really need access to some kind of thread pools, right? Properly managed thread pools, capable of being monitored, etc. In an application server or platform as a service environment, that means usually grabbing some kind of managed thread pool from the environment, integrating it into the Spring application context. JSR 236 is a great way of doing that, and a standardized way of doing that. There's support for JPA 2.1, Hibernate 4.3 of course, Spring Validation 1.1, Hibernate Validator 5.x. We have support for JTA 1.2. You can use the standard transactional annotation from JTA 1.2 with Spring components. There's general compatibility with Jms 2.0. Everything Jms 2.0 allows you to do, you can also do through Spring's Jms support. And as of Spring Framework 4.1, there's even JCache support. JCache didn't actually make E7, so that's kind of a little, that's why it's slightly at odds with the tagline. It's not actually in E7, it was meant to go into E7, but they failed to make the deadlines that the JCP imposed on the expert group. It got released a little bit later, March, April this year. As of Spring Framework 4.1, there's like full JCache support. The JCache annotation arrangement is fully supported in Spring. You can use JCache standard caching annotations. Spring auto detects them, automatically applies them. And of course, you can work with JCache providers, right? JCache compatible cache managers. And just summarizing a few of the latest servers that we are optimizing for, that we have dedicated support for. Tomcat 8 got released this year. Jetty 9.2 is the very latest in Jetty. We're tracking 9.3 as well. Glassfish 4.1 got released in August. Glassfish is a little bit of a special beast, but as of 4.1, it's actually became kind of an up-to-date platform to work with again for Spring-based applications. WebLogic 12.1.3, as oddly versioned as it may seem, is actually the first WebLogic version that introduces some E7 support. It introduces GSR 356 WebSockets, some JPA 2.1, for example, and the general WebSocket support in WebLogic to begin with. Spring ships adapters for WebSocket upgrade strategies, and we support all of them, Tomcat Jetty, Glassfish, WebLogic, for Spring-driven, Spring-initiated WebSocket upgrades, which is not actually covered by the 356 standard. We're also testing with the Liberty profile in WebSphere, which is quite interesting the way it evolves. And Undertow, the web server behind Wildfly, has some dedicated support as well for embedded bootstrapping of an Undertow web server within a Spring-based architecture. And of course, deploying a WAR file on Wildfly is a first-class target here as well. So this is what we're currently been working with for 4.0, 4.1 in particular. Now, let's dive into the design perspective. This is basically the context that we're working with, external server specifications that we're integrating with, JDK levels, JDK generations that we're working with. Now, a quick review of the Spring component design. Let's start with just a brief glance at the basics. This is about impressions, by the way. I'm not going to explain every single detail. Won't work out in that time frame that we have here. So take it as a kind of almost visual impression. This is the source code that you'll find in front of you when building a Spring-based component model, a Spring-based system, using your favorite IDE. A modern-day Spring component looks roughly like this. We tend to find a lot of service interface arrangements still, interface-based implementations. They happen to use annotations to express certain characteristics, such as their role. They say, I'm an @service, formally declaring a role through a stereotype annotation, something very common and almost enforced in Spring these days. There are dependency injection annotations. @AutoWired, sitting on a constructor here could sit on a field or a setter method or any injection method, really. Expressing dependency injection demand, describing kind of expressing that demand through a descriptive annotation sitting on a constructor. This constructor is auto-wired, is to be auto-wired. At runtime, of course, the framework may use these pieces of metadata to just infer default behavior, to infer default demand from a Java class, right? So it's going to find out that this constructor is annotated with that auto-wired. It's going to choose this constructor for instantiation of a component instance, and it's going to satisfy the dependencies. It's going to find a matching account repository bean and inject a reference to it into this constructor, unless there is more specific external metadata overriding it. @transactional, sitting on this update book method here, expresses transactional demand. But of course, it also reads nicely. From a source code perspective, this update book method is transactional. You can even go a little bit more concrete and say transactional read-only equals true. This is primarily descriptive. You're basically formally specifying certain characteristics of your implementation, of your source code, just using annotations in the Java source files, supported by the compiler, and formally readable at runtime using reflection, using annotation lookups. The framework, of course, has concrete support for this piece of metadata as well. It can translate transactional annotations into concrete transaction boundaries at runtime if transaction management is active, if you actually define the concrete transaction manager and activated transaction management. The framework is going to start transactions right before entering that method, and it's going to commit or roll back right at the end, right? This is basically the these are the core principles in the design behind Spring's annotation-based component model. Now, we have an interesting little kind of concept here in Spring in recent years called configuration classes. A typical configuration class would look like this here, with a special stereotype. It's a configuration class. We're actually following our stereotype principle. My bookadmin config is a configuration class, and it formally says so. Configuration classes can have any number of add-bean methods. Add-bean methods are basically bean declarations. You're defining a specific bean. The bean name is the method name by default. The bean type is the method's return type. And every time a new instance of that bean is to be constructed, this factory method is going to be invoked. It's kind of a little bit of a just flip over from a traditional component. A traditional component is a standalone class and constructed through a constructor invocation. That's a very typical case in Spring. And it can declare itself as a Spring bean through a stereotype on top, through being registered with a Spring container, really. With an add-bean method, you have a kind of different arrangement. Configuration classes defining those instances, naming them, adding characteristics to them, like assigning a session scope to them, and the factory method being invoked whenever an instance is needed. A pretty powerful concept, in particular for non-trivial construction algorithms that you may have, lookup algorithms that you may have to integrate, but also just for the pure convenience of like a kind of separated configuration arrangement, nicely readable, and just aggregated into units of configuration. There can be any number of configuration classes in the system. We'll see a little bit of this in further examples, but I'll just run you through core principles first, and we'll move up to concrete use of this in recent framework features. Composable annotation, something to be found in many places in Spring now, both in Spring Framework itself, in particular in Spring Boot. If you happen to have Spring Boot around, then just double check what the declarations of Boot's annotations look like. Almost all of them are meta-annotated. So they are kind of special annotations that Boot may provide as a convenience. They are meta-annotated with standard Spring characteristics, kind of combining those characteristics into one convenient annotation. You can do this yourself. It's actually primarily meant as a tool for, well, you as application architects, as application developers, defining a couple of annotations, such as this custom MyService annotation, meta-annotating it with common rules. Those are all standard Spring annotations: add service, add scope, add primary, add transactional, with specific setups for like rollback rules and whatever it is, and then just combining this into one single add MyService annotation. Every time you're saying add MyService, you're actually saying the combination of the characteristics above. This can be seen as a shortcut, but it's not really just a shortcut. It's a custom stereotype. You can freely name this custom annotation. You can give it a name that makes sense in your context, in your application architecture. And it also happens to declare your desired default characteristics. If you want standard service components in your architecture to be transactional by default, this is an easy way of achieving it. A custom, very powerful, and descriptive way of achieving it. Right, that's composable annotations for stereotypes. Composable annotations can also be used for almost any annotation in Spring these days. We kind of went further and further in our support for composable annotations. You can build custom scoping annotations. I'm not using the best possible names here, right? Obviously, you wouldn't really call it my session scope, but I hope you get the point. A custom name of yours. This custom scoping annotation is meta-annotated with add scope and a certain, session key, a certain scope key. It actually becomes type safe through the choice, right? A custom scoping annotation can be designed such that the scope key just sits in the annotation declaration, and use of the custom scoping annotation is type safe from the application's perspective. There's no need to repeat the session string key. There's actually a pretty fancy feature here. You can even redeclare a couple of attributes, if you need to, if you choose to do so, that overrides standard attributes in the Spring annotation, the corresponding Spring annotation. This custom scoping annotation has a proxy mode attribute. Proxy mode is actually redeclared from the scope annotation itself, from @scope. @scope has proxy mode as well. In this particular case, my session scoped kind of is hard-coded to be a session scope, but it leaves the proxy mode choice up to the user of the custom scoping annotation. If you choose to do so, if you don't declare proxy mode, users of your annotation cannot choose the proxy mode. They have to live with the proxy mode that you chose, or the default proxy mode anyway. Proxy mode is like security proxies, interface proxies, that kind of choice. Another variant of doing something like this is this custom transaction annotation down here. My transactional, meta-annotated with @transactional, choosing like an overriding rollback rule, and redeclaring the read-only attribute. So you have a custom transaction annotation, not allowing all the settings that standard @transactional does, just allowing a very specific one, read-only, the read-only flag, and a subtle but important point here, it actually enforces the read-only flag. It does not declare default. Use of the custom myTransaction annotation forces users of that annotation to say read-only equals true or read-only equals false. The standard Spring annotation defaults to read-only equals false. So you can actually design annotations and kind of guide users of those annotations through the way that you declared them, through declaring specific attributes but not others, through declaring default values for specific attributes but not others. So it's a quite interesting kind of toolbox. Composable annotations are a great toolbox for application architects to provide some guidance across a larger code base. All right. Let's move on to a couple of core container features. And some of the concepts that we talked about reappear. There's admin methods above. Like typically, you would find them in configuration classes. Let's just assume they sit in some configuration classes. Not necessarily in the same. They can sit in any configuration arrangement. We happen to have one admin method building a myRepository of account, generically declared for the account type, and one for product. Of course, we assume that the myRepository interface, that's an interface that you built, has a type variable, right, that we substitute here. As of Spring Framework 4.0, Spring fully evaluates such generic type structures. So in a different class in your code base, where your myBookAdmin service says, I want this myRepository for account, of account. And that's how I declare it in my constructor signature. This constructor down here at the bottom is pretty specific, right? It says, I want a myRepository of account. The framework is, as of 4.0, now fully capable of doing a type matching algorithm where it finds the most specific match for this generic type declaration without any additional metadata. So myRepository account is going to be matched with myRepository account above. You're not going to get an exception, there's more than one myRepository bean or the like. It's going to pick this one, myRepository of account, above, without the need for qualifiers. In previous Spring versions, you would have added a qualifier usually, like add qualifier account or something. Some custom qualifier to select. Now, if the type declaration itself is expressive enough, there's no need to repeat yourself, no need for additional qualifiers, if the type information is expressive enough. It looks actually like this is just a key comparison here, right? My repository of account above and down here, but it's actually a type matching algorithm. Anything that is assignable according to the Java compiler rules, anything that the Java compiler is going to accept as a kind of right-hand side to left-hand side assignment with a generic type declaration on both sides, anything that matches there also matches here. So you can declare specific implementation classes above. As long as they are internally declared and compatible with my repository of account, Spring is going to find them. You can even use collection and list injection, as we're going to see, with generic types. So this is pretty powerful, and it's a runtime type matching algorithm, which in itself is a pretty unique feature, in particular in more complex type arrangements. So, collection injection, right? My bookadmin service has a list of my repository. What would that mean? Spring just goes hunting for all compatible beans and aggregates them into a list and injects them into the constructor. So if we happen to have several my repositories of account above, we're going to aggregate them into a list. We can even order them through order metadata. So the one with the lowest order is going to appear first here. The idea is that components may send out events, and they may have kind of listeners of some kind, and they find them through a check in the container. They just say, dear container, give me everything that matches this specific signature. And in particular, event listeners happen to be generically declared very often. It's also no problem at all that both of those beans above have the same return type. They are both declared as my repository of account. Not a big deal in Spring at all. This is not a key. It's just the type. And on type matching, we'll find all matching beans of that type, all beans that are assignable to the desired target type. So collection injection, even with an ordering twist in here. Injection points can be lazy. So the add lazy notation in Spring actually has a little bit more use now, even being used at the parameter level for a constructor argument, right? Add lazy my repository of account in the constructor signature down here means I need this bean, I want it injected into my constructor very early, but I'm not going to access it right now. I'm okay with a lazy initializing proxy. Kind of a lazy, a decorator for it, a dynamically generated proxy that lazily initializes the target bean and talks to the target bean on invocation. This is a pretty powerful concept in general, since actually many dependencies are lazy in practice, if you're using constructor injection in particular. Circular reference resolution is much easier if some references are lazy. Because the framework can make assumptions about lazy references. They're not going to be used in the invocation of that constructor. So add lazy can now be used at the injection point level, and of course can still be used at the declaration point, like above for the add bean method or on a regular add service bean, right? You can just say add lazy next to it, means the container itself is going to lazily initialize that bean if it is a singleton. Lazy at the constructor level has a slightly different meaning. It means the component that this is being injected into declares that it is not going to immediately talk to that bean. Same annotation, slightly different meaning, but works great in combination at runtime. An important story in Spring's annotation-based component model is the use of standard annotations. And what you can see here is well, the most core that you could get with this. The myBookit service example, declared with a standard javax.annotation.managedBeans, like a sort of very primitive stereotype, not composable or anything, but lives in the javax.annotation package, so can easily be used for the purpose at the type level. The injection point is declared as add_inject, using the add_inject annotation from javax.inject, JSI 330, a specification that we are very involved with, kind of the most common implementation used with that particular spec. So that's an alternative to Spring's add_autowired. Almost identical in semantics. You can't express the required flag, but that's the only drawback. And at predestroy, at post-construct, also coming from JSR 250 from the javax.annotation package, can be used to identify destruction callbacks and post-initialization callbacks in Spring. In Spring, you would call this like a destroy method or an init method. We are supporting using standard annotations for those purposes. Based on such arrangements, you can quite easily have a larger code base being Spring-based in its arrangement, but declaring its requirements, its demand, through standard annotations with hardly any Spring imports found, if you choose to do so, right? There are obviously drawbacks of some sorts. Many Spring annotations are significantly more powerful than the standard versions, but the 80-20 rule applies here. If you're happy enough with 80% of the functionality, in particular in large parts of your code base, This is a great way of achieving it. If you have more specific demand, you can always opt to choose the Spring-specific versions in some component classes that actually need it. This can be mixed and matched. Spring does not ask you to choose between different sets of annotations. It usually allows them to be very naturally mixed and matched in component classes next to each other, to some degree even within the same component class. A nice twist with the standard annotations is another standard piece, Java util optional, coming in Java 8. Java 8 has this optional type primarily used in its own Stream APIs, but this is a nice way of expressing optional dependencies as well. So Spring Framework 4.1 supports what we're seeing here, declaring a specific dependency at the constructor level here with an optional kind of holder around it, optional of my repository of account. This is a Java util optional type, so you can do Java util optional like things, such as asking it for is present, or chaining processing callbacks with it if present. And Spring perfectly understands what you declared here. It knows that you want a my repository of account, it understands the generic declaration, and that you want it in an optional wrapper, which means if it's not present in the Spring application context, you're getting an empty optional instance here in a Java 8 compatible form. So this is a nice combination. Look at the imports. Standard imports all the way. Spring, by the way, automatically understands this. There's no need to set it up. Just run on Java 8, have the JSR330 annotations on your class path, use them, and Spring is going to automatically react to them, if you choose to support annotation-based components to begin with, right? It's as easy to use them as Spring's own annotations. No extra setup necessary whatsoever. Another Java 8 twist, the use of JSR310, the java.time package in Java 8. Just an example of what you can do, a brief glance at what you can do with Spring's data binding. If Spring data binding encounters a clause like this, like a customer having a birthday declared as a local date, a java.time.local date, and their last contact as a local date time, Spring understands those types. These declarations here are pretty expressive, right? We're not running into Java util date kind of ambiguities here. The declarations that you chose in this piece of source code are pretty specific. We know that the local date is a date and not a date timestamp. So we can infer certain rendering rules, binding rules and rendering rules from the very type itself. In a Spring context, this means that the Spring formatting framework does not ask you to repeat that information in an at-date-time format annotation. If you want a specific formatting and rendering rule, Spring's at-date-time format is a great way of associating with it, of associating that rule with your field. But if the field itself is expressive enough to suggest a default rendering, such as the ISO date, time, and date time renderings, then you don't have to repeat it. That's why the annotation above is commented out. It's actually redundant if the type itself is expressive enough. A general story in recent day Spring. Don't repeat yourself. If the type information is expressive enough, there's no need to add annotations for it. Right, some additional mix in here is the use of JSR330 annotations. At not null and at past are bean validation constraints coming from the javax.validation package. Spring naturally understands them if you have bean validation set up in your architecture to begin with. Then Spring's data binding integrates with and Spring's validation step in particular integrates with the bean validation engine, naturally understands those annotations. And they nicely sit next to each other in the same piece of source code. So I'm explicitly referring to the imports for your better understanding of where those annotations come from. But if you just mentally collapse the imports for a moment, it's not so important where they come from. Those annotations actually sit nicely next to each other. Next topic would be on our little tour here is scheduling and asynchronous processing. This has been around for a while in Spring, comes just with a few new twists. So you may have used it before. There's @async, kind of asking Spring to intercept a method call, to send it off and spin it off into a thread pool that you set up for this very purpose. So it's something that needs to be very explicitly configured, but once configured, you can use these concepts across your code base, right? One central setup for asynchronous processing and scheduling, and then any use of this in your managed components. At async, just as a variation, can return a future if you want to track the execution of this spun-off task. But for our purposes today, at scheduled down here has a nice little twist to it, right? There are two at scheduled annotation on the same method. Two different cron triggers associated with the same method through a repeated at scheduled annotation. Now, would this usually work? Not really, since in standard Java, up until and including Java 7, you can't repeat the same annotation type at the same declaration point. You would have to use a nested annotation around them. We actually have a nested annotation. It's called at schedules, but it's syntactically not very nice. What you see here is actually how it can be done on Java 8. Java 8, for the first time in Java's history, allows you to repeat the same annotation type at the same injection point. Spring's annotations, the ones that are actually conceptually, semantically repeatable, are now declared as repeatable in Spring Framework 4. If you're using Java 8, the Java 8 compiler is automatically going to detect that they are repeatable because we declared them so. And you can immediately use them as seen here on this little example. That applies to add property source annotations, a few annotations in the Spring codebase. While at the same time still working the good old way on Java 6 and 7, right? You can still use the at schedules container annotation if you choose to do so. But as of Java 8, you don't have to do that anymore. And I would definitely suggest using this version, obviously, if you can. We've been referring to Java 8 a bit. Just a quick example, not the focus of today's presentation. This is the use of lambda expressions with Spring. My point is, the JDBC template API that I intentionally chose here is one of the oldest APIs in Spring. This dates back to 2003 in the current version, the current design to 2004. So it's a 10-year-old API. Obviously, it evolved over the years a little, but the basic design and in terms of its backwards compatibility, it's 10 years old. This 10-year-old API naturally works with a brand new language feature in Java. There's no twist here. There's no background hack for this. It just naturally works because it uses a convention in its template callback design that happens to be the same convention that the Java 8 compiler uses for lambdas. We use callback interfaces with one single callback method in many places in Spring. And the Java 8 compiler calls those kinds of interfaces functional interfaces and can translate lambda expressions into implementations of the appropriate callback. So this call here, it's actually the same call, just differently formatted, specifies a SQL string. The second line is an implementation of Spring's prepared statement setter interface. But that's not in your face here, right? You just specify the body of that implementation. Prepared statement passed in, you do something with it. The Java 8 lambda syntax is a great fit here. And the third line is a row mapper. The row mapper in the version below, it's maybe a little more immediately understandable what this really means, right? Those are basically alternatives to building anonymous inner classes. The first one is the prepared statement set, and the second one is the row mapper, which is called once per row, builds a person object per row. The second version uses regular Java code blocks. That's why you have to use a return statement. In the version above, notably, there's no return statement for the new person expression. According to standard Java 8 lambda rules, that's not necessary for a single line callback with the inline lambda syntax. A great fit for Spring callbacks. This is JDBC template, but the same applies to GMS template, transaction template, etc., etc. All of those 10-year-old classes naturally work with Java 8 lambdas. Right. To conclude our little tour, let's move on to specific endpoint models in Spring. There's annotated MVC controllers. I suppose most of you know the syntax here. Add request mapping methods, binding to a specific path, being able to use a path variable declaration, extracting this specific variable through parameter annotations, such as add path variable, You can do the same for standard request params, for request headers, for cookie values. You're basically building a signature for the endpoint method as you need it, and you add specific parameter level annotations to each parameter of your endpoint method to just declare how that parameter is supposed to be resolved. If not otherwise obvious how it's supposed to be resolved, annotations can be used to express guidance on how to resolve them. So that we have add path variable above, grabbing the concrete value from that path that substitutes the ID variable, converting it into a long, passing it in. In the method below, we can see an add valid annotation that triggers bean validation again, or a Spring validation step, depending on setup. So when the book object is being constructed, request parameters bound to it, it's going to be sent through a validation step first before passing it in here. Can be easily declared through add valid or add validated at the parameter level. I'm going to run you example by example through Spring's endpoints, just to give you a little bit of a broad impression here of what this looks like, because it's very similar actually. What we can see here are endpoints for stomp controllers being driven by the stomp protocol from some kind of client coming into the server, typically, but not necessarily, running on a WebSocket transport underneath the covers that's supported out of the box as Spring Framework 4. Those endpoints are designed, of course, to respond to specific kinds of stomp messages. But look at the design. Subscribe mapping, add message mapping, path bindings, and add controller annotation above, flexible signatures, only declaring what you actually need. Very similar to standard MVC endpoints, or standard REST endpoints in the Spring world. As of Spring Framework 4.1, we support the same for JMS endpoints. The metadata here can be very minimal, as seen above. At JMS listener just says, this is a listener for a specific JMS queue or topic, we're binding to it. The destination itself is, of course, needs to be specified somewhere. We are not going to guess JMS metadata for you, but we can quite nicely default it. As you can see between those two versions, the version below has very specific metadata. It has a specific message selector. It suggests concurrency guidance between 2 and 10 receivers we want bound to this listener method. It expresses a container factory for some specific factory setup in the background, JMS factory setup. So you can be very specific, but you don't have to. If you can live with the defaults, or if the defaults are specified somewhere else, the version above may be all you need. So this is annotation-driven JMS endpoints. Annotation-driven messaging endpoints as of Spring Framework 4.1. And not just for JMS in the first version, also for AMQP, using the AMQP protocol and the RabbitMQ client library for the AMQP protocol to talk to an AMQP-based message broker, non-JMS-based, right? Not using the JMS APIs. RabbitMQ is the typical example. That comes out of the Spring AMQP project. Syntactically, again, very similar, right? If you just look at the examples here. The version at the bottom is a stomp endpoint again, just for comparison. Right? This is basically all message interaction. You have messaging endpoints, incoming messages, and the endpoint producing a kind of response message. In this case, the add send to annotation is being used to suggest the response destination to send the response to, if the incoming message did not suggest a response destination in particular. That's pretty useful. And a specific twist, look at the declarations of the parameters and the return types. Message comes from the org Spring Framework messaging package here, and is a kind of common arrangement, common messaging arrangement within the Spring ecosystem these days. So you will find the same signatures with the same imports for all messaging endpoints that Spring Framework supports, that Spring AMQP supports, and that Spring Integration 4 supports. All of them use the same common message types. So you can either declare an order argument, then you get the payload directly, or you declare a message of order, which gives you a kind of message wrapper around it, with the payload, a pre-declared payload, but also allowing access to the headers, etc. So it's just a common way to express a need for the actual message wrapper, for an actual message representation with additional metadata, not just the payload. The same applies to the response, and it's even more important there, since on producing a response message, instead of just saying, here's the order status payload, convert it into a message for me, you can produce a message wrapper, set specific custom response headers, and return it. Using a common message type across Spring's different kind of messaging endpoints that are supported out of the box. An important design principle as of Spring Framework 4. So last but not least, declarative caching, the version seen here, that's Spring Framework 4.1, but using Spring's own caching annotations. So expressing caching demand through @cacheable, triggering a cache evict through an @cache evict annotation has been around for a few years. So that's annotation-based caching, annotation-driven caching from a standard Spring perspective. A couple of twists in there suggesting a default cache region above. And maybe just a quick note that @cacheable actually says this method can be used with declarative caching. So we can kind of, before invoking it, check a cache, build a cache key, try to find an object to return. Otherwise invoke it and put the object into the cache. So we can do that, but we don't have to. You can choose to not activate caching, and your components are still going to work because they don't rely on caching. That's what @cacheable means. That's why it's named @cacheable. And as a Spring Framework 4.1 twist, this is the JSR 107 version of it, JCache. In the javax.cache package, you'll find a quite rich set of caching annotations, somewhat similar but not identical in design to Spring's own annotations. This is now using the standard JCache annotations, expressing the same kind of demand, right? @cache defaults above with the cache region. Slightly different cache put syntax to be found here. Cache evict is named cache remove here, and @cacheable is cache result, right? But they're semantically, if not, they are not identical, but very similar, and for many purposes can be almost used as an immediate replacement. The use of standard caching annotations with Spring's caching arrangements, just through using them, right? Import the annotations, start using them. If you activated Spring's annotation-driven caching, Spring is going to auto-detect those annotations as well, as of 4.1. And you can even use the standard cache annotations with a non-JCache cache manager. You can use a Spring's own cache manager SPI at the back end, but the standard caching annotations on the front, right? So Spring even has kind of decoupled support for JCache at the annotation level and at the backend setup level. All right, now it's time to actually give you some other impressions. We're going to do a little bit of a live demo. Stefan's going to run you through a quick boot demo. I'm not giving away too much. Stefan, it's your turn. Okay. The idea is that we're going to show you how easy it actually is to use many of those Spring features, to use that kind of design and to get up and running with a nice little working setup and to deploy it even. Mm-hmm.
So what we're going to do in the next 12 minutes or so is to create a web application using GPA and exposing a set of, well, one actually, repository. And what we're going to do is we're going to expose that as a REST endpoint. And what I want to show you also is the non-functional features that you get with boot. So I'm going to choose the actuator here. So if you don't know that website, start.spring.io, please try it out. It allows you to really get started very easily with Spring, and Spring Boot in particular. So you can choose the deployment model that you want for your app. In this case, I'm going to choose a jar file. And I'm going also to choose the latest versions, which was released yesterday.
And it's based on Spring Framework 4.1, right?
Yeah.
So boot is basically tracking Spring Framework's own evolution very closely.
Okay. So this is my project here. Going to open that. The first thing is I've selected GPA, but I didn't choose any backend, database backend, so I'm going to add one. I'm going to choose H2 for the time being. Yep. Okay. So I'm going to create a speaker JPA entity. Nothing fancy about it. There's an ID, a first name, last name, a Twitter account, and a bio. And I'm going to create a repository interface for it. And I'm going to use a Spring Data for that. I'm going to choose the paging and sorting repository, which is basically a CRUD repository with, as you might guess, paging and sorting support. We'll see in a minute what that means. If you don't know about Spring Data, the nice thing about it is you can write query like this. And what Spring Data is going to do is it's going to infer the query to generate based on the method signature. I said that we will expose those as REST endpoints because it's always fun to show something, and since I'm a backend guy, I'm not going to pretend I can create a UI because I can't. And I'm going to tweak that a little bit, tweak the REST endpoint. And in that case of that query, if you don't do anything, it's exposed with the method signature. I don't want that, so I'm going to tweak that a bit and map the param as ID. Oh, that's not the right one. Oh, JBoss deprecated, okay. Like that. I have also a few speaker because we don't have many time to import them. So is that right? Yes. Okay. So that's regular import statement, a SQL statement. There is nothing funky about it. So if we look at the application now, you'll see two annotations you already know. Configuration, we've seen it. Component scan is basically saying that scan for the demo package and sub-packages for Spring components. And that enable auto configuration there is basically a turn that class into a Spring Boot application. And I'm using this simple static class to basically start a boot app. So let's see what it does. So it's starting something. Let's try. Okay, that's going to expose that as, that's going to use Spring Data REST, expose my speakers, so I can see all my speakers here. I can even get some detail about a particular speaker. And you see those nice URL and everything. What?
I didn't actually read that line before.
Oh, someone changed your bio. Yeah. Sorry. All right. So what I'm going to do next is I want to show you because as you've seen, I stayed in the IDE, no build, no whatsoever. I just ran the main class. So if you want to try it out and be very productive about it, that's the kind of support you get. But I don't want you to leave the room with the impression that a Spring Boot is a tool to prototype applications. So you start a simple template app, you try a few things, and when you need to do something serious about it, then you leave Boot out and you go back to regular Spring. I don't want you to have that impression. So what I'm going to do is I'm going to show you how you can put that application in production. And before doing that, I want to do something more. I want to also enable single sign-on in my app. So I have extra dependencies that I need to add there from the Spring Cloud project and the Spring Security OAuth project. I also need to do a little tweak because as you've seen, Boot actually detected that I was using H2. It detected that no configuration was there, so it created a database in memory. And there is another component that looked at the data source and figured out it was an embedded database, and it turned on the DDL generation process for me. But since I'm going to push that somewhere else, I need to be explicit about it. So I always forgot that one. Okay, this is it. So I'm basically saying, please create the database for me if it does not exist yet. Okay. let's try. So I have this devox thing. I'm going to build it. So what that's going to do for me is it's going to build a jar file, an executable jar file, with the libraries and the container in it. You've seen also on start.spring.io that I could choose WAR packaging. If you want to do that, you can do so. It will generate a regular WAR file that you can deploy on any Servlet 3.0 container. But I want to show you what we basically use ourselves. So if I do that, java-jar with the application, it's basically going to start my app the exact same way as it was doing in the IDE. I said I wanted to, oh, yeah, okay, I knew I forgot something. I said I wanted to enable single sign-on. This is it. And I should probably rebuild. Maybe quicker. Yeah, you know, even us, we do that from time to time.
We need to cut that out of the video. Didn't happen to skip test.
I only have 5 minutes left, you know. I could have written a test for that. I actually did on Monday. Where is my password? There we go. So yeah, I want to enable single sign-on, but you need to provide some information to the application for that. And I haven't provided any of those. So it's going to fall back to the default security behavior. And the default one is to secure everything with basic authentication with a generated password on startup. So if I do that, I'm back on my speaker again. Okay? But now I want to use single sign-on. So what I'm going to do is, I won't change the file at all, and I'm going to push that to the cloud. So I'm going to provide some metadata about my app, the name. You can provide a bunch of things. And I'm going to say that I want to bind the app to 2 services. One is SSO, and one is Devoc Postgres, I think, which I created this morning. SSO is what we call in Cloud Foundry a user-defined service. That's basically a way for you to specify properties, and when you bind that service to your app, those properties are made available to your application. So in that SSO service, I've defined the URI to connect to the login page, the URI for the authorization server, the client ID and the client secret. I can't share those, obviously. So if I look at what I have here, that's probably CF service, right? Yeah. Just to make sure I didn't make any typo. There is this Devox Postgres. Is that what I type? Yeah. So I'm going to log in here, just to make sure I'm logged in. And I'm going to push the app, right? So that's the same jar file. It's really important that you understand that. And what the Cloud Foundry push is going to do is going to do several things. The first thing it's going to do is look at my jar file and figure out that there are libraries in them, and send the signature of each library to the server saying, do you have that library? And if the server replies, yes, I have it, it won't be uploaded. So that's why you get this 802K being uploaded. So all the libraries were not uploaded. That's the first thing it's going to do, which is nice. You can actually push an application on 3G if you want. The second thing it's going to do, it's going to look at the service that you have bound to the application. And it will figure out in this case that I've bound that to a PostgreSQL instance. So you've seen I didn't add the PostgreSQL JDBC driver to my app. It's going to figure that out for me, and it's going to add the dependency to the PostgreSQL driver. Okay. Starting.
The challenge of doing a live demo against a, well, Pivotal Web Service. It's a public Cloud Foundry instance, right? So we are not using a fake setup here. It's really the public instance that you could be using.
All right. So the app is started as devoxcfapps.io. Let's try. Oh. That should have worked. Okay, what did I miss?
Again?
I think there's a problem with the bindings. Devox service SSO, Devox Postgres. Okay. There's two things that are real with the app is I don't see the binding with the proper service. It should have worked. Devox. Yeah, I know, I'm late. Maybe didn't use my manifest. Oh, that's it. Okay. Did I make a typo in the manifest, maybe? Ooh, that's an excellent point. Yeah, maybe I didn't save it. Okay.
Oops.
Oopsie, oopsie. Okay, using manifest, that's better. Thank you.
Oh, thanks, yeah. One more iteration.
So now you need to dance a little bit because we have to wait for 1 minute the application to start.
Taking the opportunity, what you're seeing here is a lot of stuff that we've been doing recently around Spring Framework itself. That's Spring Boot. So the pieces that are involved here are Spring Boot, recent Spring Data versions, our Spring Cloud initiative, many things that bring these core Spring concepts and the core Spring design onto like the most modern infrastructure you could possibly imagine. The Cloud Foundry has been around for a few years, right? So it's very central to Pivotal's own mission. It's also a really nice way to show how easy it is to deploy a Spring Boot application, a self-contained Spring Boot application to the cloud. But obviously, any cloud-based demo has the potential to
20 more seconds.
Yeah,
okay.
to
Find
use a little bit of waiting time, right?
Yeah, go ahead.
Just to clarify, Spring Boot is of course not bound to cloud deployment, right? Spring Boot can be used for many purposes. You can build WAR files, you can build standalone jar files with Java-jar deployment, but you can also very easily deploy a Spring Boot derived unit to any cloud really, but in particular also to Cloud Foundry. So, one more try?
Yeah. Okay. So no login. And I want to show you what happens if I'm incognito, so I'm just disabling everything. That's basically going to redirect me to whatever I need to do. And it will nicely do it.
Right.
That's about it. Let's just go to speaker 0 so that you can take a picture if you haven't done so yet. All right. Any question? Our time is up, I think.
Yeah, time's up. We're here anyway, so if you have any questions, please approach us here or anywhere else if you find us around today. Thanks for your attention. I hope there were interesting impressions for every one of you. And if there's any follow-ups, if you'd like us to clarify stuff, please reach out to us. We're easy to find, easy to reach, and enjoy playing with this stuff. Thank you.
Thank you.